Here is a short review video for all of your integer operations. There are 5 different methods you can use or think about as you solve addition problems involving integers. That list is on the side in green. If you prefer thinking about temperature, you might want to ask if it makes sense with the problem. For example, -5 plus -3. If you think about that in terms of temperature, that would mean that the temperature starts at 5 degrees below zero and increases by a -3 degrees. You'll never hear anyone talk about that, so temperature would not be a good one to use for this problem. Your next option is to think of it in terms of money. -5 represents a debt of $5. -3 represents a $3 debt. Well, you can put together a $5 debt and a $3 debt, and that's a total debt of $8, which ends up being the integer -8. If you want to solve this using a number line, I'm going to put, and I can draw this problem. The number that I'm starting at is -5, which is 5 places to the left of 0. 1, 2, 3, 4, 5. I look at my first sign, which is an addition sign, which would tell me to go right. But then I see a negative sign, which says I should go left, and I need to go to the left 3 places. 1, 2, 3. And that number ends up being -8. And last but not least, you can use the counters to show what this means. This would mean that you start with 5 negatives and you are adding 3 more negatives. In total, you have 8 negatives, which represents the number -8. Now I am going to work through the second problem, working through all 5 methods that you could use. First, if you choose to think of temperature, this would mean that your temperature starts out 4 degrees below zero and increases 16 degrees. If you start at -4 and it increases 16, you would end up with a temperature of 12 degrees. If you think of it in terms of money, -4 represents a debt of $4, and adding 16 would be getting or receiving $16. Well, if you get $16, you need to pay off your debt of 4, and you would have $12 left. On a number line, you would start at the number -4, which is 4 places to the left of 0. 1, 2, 3, 4. Adding 16, or that addition sign, means you need to move to the right 16 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You would end up here, which if I go back and count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You end up at +12. If you show this with number chips, you would start with 4 negatives, 1, 2, 3, 4, and you are going to add 16 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Whenever you put positives and negatives together, they cancel out. We call those 0 pairs. So what you have left, if you go through and count, is you have 12 positive signs, which represents the number 12. And don't forget your rules. If you don't want to spend your time drawing counters or number lines, you can go back and use the rules. If you go back and look at the first problem, you are adding numbers with the same sign. They are both negative. So all you do is add these numbers, 5 plus 3, which is 8, and you keep the sign, which was negative. On the second one, the rule says you are adding a negative number and a positive number. When you add negative numbers, you subtract these. So 16 minus 4 is 12, and you keep the sign of the larger number, or the number that has the largest absolute value. 16 is positive, so your answer has to be positive. You can follow your addition rules if you simply change subtracting to adding the opposite. So we are going to go through, and every time we have a subtraction problem involving integers, we are going to change it to adding the opposite. So in this first problem, 6 minus 11, we are going to change our subtraction sign to addition, and then we're going to make our second number the opposite. The opposite of 11 would be negative 11. From there, you can follow those 5 steps or those 5 options for adding integers. You can think of it using temperature, money, you can draw number lines, you can draw number chips, or you can follow the rules. This first one, I'm going to remind you what it should look like with the number chips. So if I change this to 6 plus negative 12, that would look like 6 positives. And you are adding 11 negatives. And you want to cancel out or make those 0 pairs with your positives and negatives together. And if you would count what you have left, you have 5 negative signs, which represents the number negative 5. Or you can follow the rules. You are adding numbers with opposite signs. You're adding a positive number and a negative number. So what you should do with those is subtract these numbers. 11 minus 6 is 5. You keep the sign of the larger. 11 is bigger than 6. It is negative, so your answer has to be negative 5. On the second problem, change it to adding the opposite. Again, another reminder, you don't ever change the first number. You change a subtraction sign to addition. You make the second number the opposite. The opposite of negative 4 is positive 4. So what this problem becomes is negative 8 plus 4. Again, you could draw this on a number line. You start at negative 8, which is 8 places to the left of 0. 1, 2, 3, 4, 5, 6, 7, 8. And adding 4, you see an addition sign, which means go right. Another addition sign, which just means keep going right. 4 places. So you end up 1, 2, 3, 4. Which is a number 1, 2, 3, 4 places to the left of 0, which is negative 4. Or, if you use those rules, you look and see that you are adding opposites. So you simply subtract these two numbers. 8 minus 4 is 4. 8 is bigger than 4, and it's negative, so your answer is negative 4. It shouldn't matter which method you use. You should always end up with the same answer. Finally, multiplying and dividing integers. You multiply or divide as indicated, ignore the negatives, but then when you're done, go back and check how many negatives there were in the problem. Remember, if there is 1 negative, your answer is negative. If there are 2 negatives, your answer is positive. And then remember, if you have a problem that involves more than 2 numbers, if there are 3 negatives, it would be negative. If there's 4 negatives, it's positive. So any odd number of negatives will be positive, and any even number of negatives will end up being positive. So this first example, negative 4 times 2, ignore those negatives and just multiply 4 times 2, which is 8. Then you go back and count. I have 2 negatives, so that makes my answer positive. In my second problem, I have negative 15 divided by 5. All I'm going to do is focus on the division first. 15 divided by 5 is 3. Then I go back and count, and I only see 1 negative, so my answer is negative 3.